So in this video, we're going through question 9 from exercise 18E. Let's give it a read. It says, let f be this. So we have a function here, which is 2 minus 8x squared. So we know we're dealing with a parabola. We also have a restricted domain here between -2 and 2. So that's going to come into play. So that's going to be important. Let's keep reading. It says find the absolute maximum value. So we need to find the absolute maximum and the absolute minimum value of the function. Now, before we dive into all our fancy calculus, let's just give this thing a bit of a graph so we know what we're looking at. So I have 2 minus 8x squared. Because it's got a squared there, I know I'm simply dealing with a parabola, so a parabola. Because I've got a negative in front of my x squared, I know it's going to be upside down. And because I've got a 2 here, I know it's going to be shifted 2 up. So with those pieces of information, I can quickly give this a sketch over here on my axes. So let's give that a sketch. It's an upside down parabola shifted 2 up. So let me draw that. Let me actually try that again. It's going to look something like this. And I want to try one more time. I want to get this thing looking good. Something like this. All right, not the greatest in the world, but it will do. And this is going on forever. All right. Now, we also have this restriction right here. We have a restriction between -2 and 2. So let's put that in. Let's say that right here is -2 and over here is 2. And it goes without saying that these are x values right here. It's x equals -2 and x equals 2. So that's why I've put them on my x-axis. Now, if they're restricted here, what that's going to mean is that my graph isn't going to go on for infinity. It's actually going to stop right there. And so too over here, it's going to stop right there. I might even try to make this a little, let me just move this over a little bit. Perfect, so that looks a bit better. So it's stopping at x equals 2. So too over here, at x equals -2. So that means stopping here. Perfect. Now, here's the great thing about this question. You could figure out what the absolute maximum and absolute minimum values are with no calculus at all, because by looking at this, you can immediately identify that this point right here, well, it's my maximum, isn't it? It's going to be my absolute maximum. And it's going to occur at this x value. And what's that x value? Well, it's x equals 0. So just like that, we've solved the question. And over here, this is going to be my minimum. This is going to be my minimum. And over here is also going to be my minimum. Both of these are going to share the same y value, which you can see there. They're showing the same y value, and therefore it's going to be the same absolute minimum. So I just have 2 of them. It occurs twice. And that's going to be at x equals -2. And this is going to occur at x equals 2. So just like that, we have solved this question. We know when the maximum is going to occur, and we know when the minimums are going to occur. But let's now do this with a bit of calculus. So to find out what my stationary points are going to be, what we do is we differentiate f here. So that means I'm going to get f dash x, and I'm going to differentiate this. My 2 here is a constant, so it just goes away. So I'm going to get -16x. Now, to find my stationary points, what do we do? To find stationary points, I'm going to set my derivative to 0, and I'm then going to solve for x. So I'm setting my derivative to 0, and then I'm solving for x. Solve for x. Perfect. So we've got that there. So let's now do it. So this will be 0 equals -16x. I'm then solving for x, so I'm going to divide both sides by -16. 0 divided by -16 will be 0, and right here this will cancel with that, so I'm just going to be left with that. So that means at x equals 0, I have a stationary point. And if we come over here, you can see I have one stationary point. It's right here. This is my stationary point. It is my stationary point, which makes perfect sense because it's my maximum point. There's going to be one maximum, one stationary point right here. This one right here. And look, it occurs at x equals 0. That's what we found out over here. Isn't that amazing? We did something without calculus. Perfect. Now, we have to prove that this is a maximum. Sure, our graph says it, but we need to prove it. So we need to prove the nature of this stationary point. The way that we're going to do that is, you guessed it, with a table. So what do we do here? Well, I'm going to say that this is x, this is f dash of x, and here is my shape. So in the middle, we're going to put in our stationary point. So right here, I'm going to say at x equals 0, I'm going to have a derivative of 0. And then I need to test both sides of it. So let's test this side right here. So what I'm doing is I'm finding what the derivative is going to be of this side of my graph. And we can see if I drew in a tangent here, it's going to be positive, it's going up. So let's do that now. So if I went f dash of -1, so I'm taking my derivative and I'm subbing in -1. -1 times -16 is going to be positive 16. My negatives are going to cancel out. So this means this is 16. 16 is a positive number. It's going up, just as we saw here. Then I have my stationary point, so it's going to be there. And now I'm going to test a side on the other side of my stationary point, so now 1. Now, if I was to draw in a tangent at that point, it would be something like this. And as you can see, my tangent is going down. It's going to be negative. So let's now prove that. If I subbed in 1 into my derivative, I'm going to get -16 and 1, which is going to be -16. So I get negative here. Because it's a negative number, it's going down. And just like that, we have proved that at x equals 0, we have a maximum, an absolute maximum. We have an absolute maximum, And if you wanted to, I don't think the question asks for it, but we could find what the coordinate of this is going to be. So the way that we would do that is we know that the x value is going to be 0. And then if I was just come down here, I would say, all right, what is f of 0? So f of 0, I have to remind myself what this function was in the first place. It's 2 minus 8x squared. So it's going to be 2 minus 8, 0 squared, which is going to be 2 minus 0. So it's just going to be 2. So right here would be 2. So we found that just by subbing in 0 into my original function. So this point right here, if we were to write it in, I've got lots of arrows pointing to it, would be 0, 2. This point right here. That is my maximum. It is my stationary point. Beautiful. Let's now go and find out what my minimum is going to be. Now, when finding what my minimum is going to be, it's just going to be here, right? It's going to be here and here. I don't need to do any calculus to do that. I can immediately, after drawing my graph, say that this is going to be at x equals -2 and 2, we have absolute minimums. We have an absolute minimum, absolute min. And this is going to be here and here. Now, if I only got one stationary point when I did my differentiation, and that's because it's only stationary here. These are minimums because that's where I'm being cut, because I'm restricting my domain. And again, if you wanted to find what the y values are going to be for this, you would have to go f of 2, then it would be 2 minus 8, 2 squared, which is going to be equal to 2 minus 8 to the 4, which is going to be equal to 2 minus 32. So it's going to be equal to -30. So that means this point right here is going to be 2 -30. And I could also find what this is going to be. I can immediately tell you what it's going to be because I know it shares the same y value. It's going to be -2 and -30. But just to prove to you that it is, let me do it again. So if I went f of -2, I'm going to get 2 minus 8, -2 squared is going to be equal to 2 minus 8, 4, because my negative when times by itself is just going to go away. So I'm going to get 2 minus 32 again, which is going to be -30. So that means this point here is -2, -30. So we have now solved this. At x equals 0, we have an absolute maximum, and I've written down my coordinate. And let me write down my coordinate here. My absolute minimum is going to be at 2, -30, and also at -2, -30. And just like that, we have solved this problem. We have found the absolute max and absolute min. We have done it by doing a bit of calculus, a bit of graphing, all great stuff. Let's zoom out and appreciate what we have done here. Hopefully this video has made sense, If not, please reach out and I can explain it to you again. I hope this was helpful, and I'll see you in the next video.